Let's take a look at Leet code question 74, search a 2D matrix. And this is a great question to help you practice your logarithm time complexity algorithms. It builds up on the binary search algorithm, so it's essential that you watch that for this video. And we'll see a time complexity of n log n. So if you haven't seen any time complexities like that, and you also want to practice your binary search, both two critical things to understand in algorithm questions, and this is the right video for you. You are giving a m by n integer matrix. So m's the rows, n is the columns. And with the following two properties, each row is sorted in a non-decreasing order. Non-decreasing mean it's in ascending order, and it's possible to have the same number, but it should always be, the next number will always be bigger than the previous one or equal to. And the second condition is the first integer of the row is greater than the last integer of the previous row. So you're given an integer target and you need to return true if the target is in the matrix or false otherwise. And then there's also this caveat that the solution must be in m log n time complexity here, log m times n time complexity. So let's just take a look at an example. We have 3 rows and 4 columns here, and the target here is 3. So we need to go through each of these rows, which are in ascending order, and we know that the next row is bigger than the previous row. So to be able to solve this, you need to be able to know how the binary search works, because essentially binary search works by making this more efficient, and you've seen that was log of n time complexity. So essentially all we need to do is do binary search for each of the rows, since we know that the next row is going to have a bigger number and all the other numbers are going to be bigger than what was searched in there. So binary search, just rather than searching through every element, which will be O of n, and any row, and if every row and column needs to be searched through for a 2x2 matrix, or a matrix of 2 dimensions, that would be n squared or m times n. So rather than doing that, we can take advantage of the binary search, which you know is log n, which essentially just halves the numbers of values that you're searching for, since they're sorted each time, and then we can solve the question iteratively using that approach for each row. So it's a great question, and binary search is super important, so it's good to be able to practice that. So let's just go ahead and write the code for this. So essentially what we can do here is I'm just going to go ahead and paste the binary search from the binary search algorithm question that we done in the previous video. And then what we can do is we can just have a for loop here. So we're going to loop through each of the rows. So each row has some numbers associated with them. So we're just going to loop through each of our arrays of numbers. And then all we really need to do is we just need to determine if we have a number or not. And then we can just make use of our binary search function, pass in the row numbers and the target. And if that's not equal to -1, because -1, recall, is the case that nothing was found or wasn't found. If it's not equal to -1, that means something was found, and then we can get the number. And then if we have a number, we can simply return true here. Otherwise, we can return false. And we know that this runs in log of n time. So log of n, if we take a look at our diagram here, we can see that, and that doesn't need to be so big. If we look at our rows, we're passing in the rows, so all of the numbers in each row. So for this first row, we're passing in 4 elements, which corresponds to the m value, because we've got an m by n matrix. So the number of rows m and the number of columns is n. So for each row we have all of the rows columns in that row. So that means this search function is going to be log of n, because the number's length is of n. And since we got the for loop for the rows, that's going to be m. So we know for loops, they are of time complexity n usually, but we're going to base it off the row, which is m, and we need to distinguish it from n in this case. So we can just simply multiply. So for every row, we need to perform a operation, a binary search operation. So we can just multiply m by log of n. And that's better than m times m, which would be m squared. So the space complexity here is just O of 1, because we know that the binary search is O of 1, and then we're not really allocating any memory other than this variable here. So that's how we can determine if a matrix has a number or not. So let's just go ahead and submit that code, and we can see that it beats 75% of users with TypeScript, so that's pretty good.